Hello and welcome to Math Zone African Motives. In this tutorial, we will be covering Unit 1-2, which is all about second-order determinants. By the end of this video, you will be able to define what a second-order determinant is, identify its components, and confidently evaluate any given second-order determinant. So what exactly is a second-order determinant? First, let's understand its structure. In simple terms, a determinant is a number or a scalar that we can calculate from the elements of a square matrix. A second-order determinant comes from a 2x2 matrix. Let's look at Figure 1.3 to understand this structure. As you can see, a second-order determinant is represented by four elements, A, B, C, and D, arranged in 2 rows and 2 columns. Let's visualize this. We can see the first row, which contains the elements A and B. And here's the second row, containing C and D. Just as we have rows, we also have columns. This vertical arrangement of A and C forms our first column, and the vertical arrangement of B and D forms our second column. It's important to be able to name the elements based on their position. We use a double subscript notation to do this. The first subscript indicates the row, and the second indicates the column. Let's label our elements using this notation. So the element A is in the first row and first column. We can denote it as A sub 1, 1, or Aij, where I is the row number and J is the column number. Similarly, B is a 1, 2, C is a 2, 1, and D is a 2, 2. Understanding this notation is crucial for working with determinants. Now that we understand the structure, let's learn how to evaluate a second-order determinant. This is the process of calculating the single numerical value from the determinant. The rule for evaluating a second-order determinant is straightforward. You multiply the elements along the principal diagonal and subtract the product of the elements along the secondary diagonal. Let's visualize this with Figure 1.4. The principal or primary diagonal runs from the top left to the bottom right. It contains the elements A and D. The secondary diagonal runs from the bottom left to the top right. It contains the elements C and B. The formula, often represented by the Greek letter delta or simply det, is this. Delta equals the quantity A times D minus the quantity C times B. Let me repeat that. Delta equals the product of the principal diagonal AD minus the product of the secondary diagonal CB. The book also shows this formula using the Aij notation. This formula is the core of our lesson today. It's the method we will use for every example. The key is to remember the order of operations. Principal diagonal first, then secondary, and you always subtract. Now, let's put this into practice with our first example. We need to evaluate a second-order determinant. Here's the problem. We need to evaluate the following determinant. We will use our formula, delta equals A times D minus C times B. First, we must identify our elements. In this determinant, A is -4, B is 2, C is 3, and D is 1. I'll highlight these in blue to make it clear. Now we substitute these values into our formula. The principal diagonal is A times D, which is -4 times 1. The secondary diagonal is C times B, which is 3 times 2. So our equation becomes delta equals -4 times 1 minus the quantity 3 times 2. Let's perform the multiplications. -4 times 1 is -4, and 3 times 2 is 6. This gives us -4 minus 6. Finally, we perform the subtraction. -4 minus 6 equals -10. Our final answer for this determinant is -10. The solution provided in the notes matches our result, which is excellent. Great, let's move on to the second part of our example. The process is exactly the same. The second determinant we need to evaluate is this one. First step, identify the elements. I'll highlight them again in blue. Here, A is 0, B is 8, C is -7, and D is 6. Now, we apply our formula, delta equals AD minus CB. The principal diagonal product is 0 times 6, and the secondary diagonal product is -7 times 8. Substituting these values, we get delta equals 0 times 6, minus the quantity -7 times 8. Let's do the multiplication. 0 times 6 is simply 0. Negative 7 times 8 is negative 56. So the equation becomes delta equals 0 minus negative 56. Remember from algebra, subtracting a negative number is the same as adding a positive one. So 0 minus negative 56 becomes 0 plus 56. And 0 plus 56 is just 56. So the value of this determinant is 56. The memo also agrees with our answer here. We're doing great. Let's tackle the third and final part of this example. Here is the determinant we need to evaluate this time. Following our procedure, we identify the elements. I'll highlight them now. A is 5, B is 2, C is 7, and D is negative 9. Notice how we always identify D first, then B. Now we substitute these into our formula. The principal diagonal product is 5 times negative 9. The secondary diagonal product is 11 times 2. So our setup is delta equals 5 times negative 9 minus the quantity 11 times 2. Let's perform the multiplications. 5 times negative 9 is negative 45, and 11 times 2 is 22. This simplifies our expression to delta equals negative 45 minus 22. Finally, we combine these two negative numbers. Negative 45 minus 22 is negative 67. And that is our final answer. The notes also give us negative 7, so our work is correct. This final example confirms that our method is consistent. Let's quickly recap what we've learned. We set out to define second-order determinants and learn how to evaluate them. And I believe we have successfully achieved those goals. We learned that a second-order determinant is a 2-by-2 arrangement of 4 elements that corresponds to a single numerical value. We also established that each element has a unique position, which we can denote as aij, where I is the row and j is the column. Most importantly, we learned the key formula for evaluating it. To find the determinant, you multiply the elements on the main diagonal, A times D, and subtract the product of the elements on the secondary diagonal, times B. We then walk through 3 examples step by step, applying this formula and confirming our answers with the provided solutions. We saw how to handle both positive and negative numbers correctly, ensuring we didn't skip any algebraic steps. This concept of determinants is a fundamental tool in linear algebra and will be very useful in solving systems of equations and working with vectors. Keep practicing. Thank you for watching this tutorial from Math Zone African Motives. If you found this video helpful, please subscribe to our channel for more math tutorials. We appreciate your support and look forward to helping you learn more. See you next time.